Hello, my name is Alex Cueto, and I will be talking about the public lecture Loop Quantum Gravity, a Bird's Eye View, presented by Abhay Ashtekar. To be brutally honest, walking into the lecture, the most I knew about gravity and other cosmological phenomena was as much as someone who'd just watched Interstellar. Given I had never really explored the field, but this lecture I definitely had the chance to do so. So this lecture discusses a new concept of loop quantum gravity. So at the beginning of the lecture, Dr. Abhay discussed the history of general relativity and Einstein's classical theory. What Dr. Abhay discussed was that Einstein, although his theory of general relativity has been monumental towards our understanding of modern physics, it lacks an ability to explain some of the missing puzzle pieces to the grand theory of gravity. He discussed how general relativity employs a geometrical approach towards solving the problems produced through modern physics. Furthermore, the theory of general relativity is incomplete by ignoring some of the fundamental concepts of quantum physics. With that said, quantum gravity comes into play to attempt and explain these missing pieces of the puzzle. In the fundamental mathematics of quantum gravity, nothing is constant, everything is varying and probabilistic. This makes a unique contrast between general relativity, which employs geometry, a set mathematical principle, which produces definite predictions. This distinction between the two really makes me want to look into the differences between the two and how scientists are trying to bridge the gap between both states. So, more information gathered by Dr. Abhay goes to show that fundamentally everything can be represented by quantum mechanics, including geometry. This distinction makes it possible to simultaneously map the equations of general relativity to their quantum siblings. In other words, producing, in other words, um, producing, I'm sorry, in other words, producing these equations for the field of quantum mechanics. This fundamental discovery are the building blocks for loop quantum gravity. The overall attempt of loop quantum gravity is to unify the concepts of gravity with the other three fundamental forces of the universe. With my fascination of such theories, I attempted to understand the concept theory, uh, competing theories attempting to solve the holy grail problem of physics, unification of the three forces. So in this case, we have two theories, loop quantum gravity and string theory. So here I have a basic kind of infographic. Also a disclaimer, please do not take these images of loop quantum theory, you can see right here, and string theory as they are. This is not an accurate representation of what they look like. But with that said, so we have these two different theories. So we find, first of all, that loop quantum theory takes the ideas of general relativity and attempts to incorporate quantum mechanics. Whereas we have string theory, which starts with quantum mechanic building blocks and attempts to incorporate gravity into its theory. So basically, this infographic also goes to show what different discoveries they've been able to make. So first of all, you can see here we have a guy with a question mark over his head, and that basically goes to show that string theory hasn't been able to make any predictions of how these three forces in gravity come together. It's been able to basically create a fundamental theory, but no predictions have been able to be tested or any sort of numbers created from string theory. Whereas loop quantum gravity has had useful information, especially coming from the apologize, coming from the the cosmic microwave background, and we've been able to basically find a wide variety of different things, including, for example, um, ours truly up high, being able to actually be the first person to predict the entropy, or not predict, but accurately measure the entropy of a black hole. And this was once theorized by Hawkins, and Abhay was able to basically recreate that. And so basically, this is a distinction of the two, and we can see that loop quantum gravity has been able to predict some things, whereas string theory hasn't really been able to predict much in terms of trying to solve gravity in the three forces. So, with that, I found this lecture to be very interesting, and it was very cool to be able to learn about the different theories that are going towards trying to find the holy grail of physics. But with that, I appreciate the time and have a nice day.